Alright, welcome back. And the new topic is applications of calculus to the physical world, or simply calculus in the physical world. And the first area in this topic that we're going to be looking at today is rates of change. So whenever you think of a rate, you should always associate it with the first derivative. So this is the definition. The rate of change of some quantity with respect to time is given by the first derivative of that function. So because it's with respect to time, that's why we've got dt, where t represents time. So the rate of change of a quantity q with respect to time is given by dq dt. So that first derivative there is the rate of change of that quantity. Alternatively, if you are given the rate and you want to find an expression for the quantity q, then to go from the first derivative back to the original function, then you need to integrate whatever that expression is for the first derivative to go back, and then use some information in the question, possibly the initial conditions or whatever other information is given, for you to find that constant of integration. Let's have a look at an example here. The number of bacteria in a culture increases according to this formula, where T is time in hours. Find A, the number of bacteria initially. Now initially means when T equals 0. So we want to find B, the number of bacteria when T equals 0. So just replacing that T with 0 and that T with 0, and you can see you get B equals 2000. So the number of bacteria initially is 2000 bacteria. B is find the number of bacteria after 5 hours. So remember T is in hours, so that means in 5 hours T is going to be 5. So when T equals 5, we just simply need to substitute that into our expression for the number of bacteria. So it's 2 times 5 to the power of 4 minus 5 squared plus 2000. And when you put that in your calculator, you should get 3,225 bacteria. So that's the number of bacteria after 5,000. So we're starting at 2,000, and then that's increased to 3,225 after 5 hours. Okay, then part C says find the rate at which the number of bacteria will be increasing after 5 hours. So remember, whenever you see rate, you should associate that with the first derivative. So we've got our expression for B. I'll just rewrite it over here. B equals 2t to the 4 minus t squared plus 2000. And we want to find an expression for the rate at which the number of bacteria is increasing. So that means we want to find the first derivative, dB dt. And so differentiating that expression, you get 8t cubed minus 2t. And this particular question is asking for what the rate is when t equals 5. So when t equals 5, we just need to substitute that into our first derivative, which is our formula for the rate of change of the number of bacteria per hour. So substituting 5 for t into the first derivative there, and you get 990, and the units for this is going to be bacteria per hour. So at 5 hours, the number of bacteria is changing or increasing at the rate of 990 bacteria per hour. Okay, let's look at another. In this example here now, we're given the first derivative, dh dt. Oops, sorry about that, dh dt. Alright, so the rate of descent of a submarine into the ocean starting from the surface is given in terms of the time of descent, t seconds, given by this expression, where h is the depth of the submarine in metres. Find an expression for h in terms of t. So to find h in terms of t, because we're given the first derivative, we need to integrate that to find an expression for h. So let's integrate. Alright, so our expression is going to be h equals the integral of 1 minus. Now we might use our index laws. It's going to be easier to integrate 1 over 1 plus t squared if we change it to 1 plus t all to the power of negative 2. So we're integrating there. Integrating both sides, I guess you could say, with respect to t. When you integrate the left-hand side, you're just left with h. When you integrate the right-hand side, you're left with this expression here. So let's integrate that with respect to t. And the integral of 1 is going to be t. When we're integrating a function of a function, we've got a linear function inside the brackets. 1 plus t is linear, so that means we can use that function of a function rule. So we are going to add 1 to the power, divide by the new power, and also divide by the derivative of what's inside the brackets. The derivative of what's inside the brackets is just 1. So we can divide by times 1. We don't really have to write that down. And then we're integrating indefinite integrals, so we'll have to have our constant of integration. Let's fix this up. That's going to be t. Okay, we have a negative and a negative, which makes a positive. And in using what we know about... So using the index, I was going to change this to 1 over 1 plus t. Okay, because we have to the power of negative 1, which makes this to the power of 1 on the denominator, but we don't have to write to the power of 1. And then we have our plus c. Now the question says to write your front expression for h as a single fraction. H in terms of t. So we've got h in terms of t, but it's not a single fraction. We also need to find what our constant of integration is. So, what information can we use in the question to find our constant of integration? Well, it says here that submarine is starting from the surface. Starting means when t equals 0, and the surface is when the height is 0, because remember h is the depth of the submarine in metres. So that means when t equals 0, h equals 0. And we're going to use that information to find our constant of integration. So, substituting that in, we will get 0 equals 0 plus 1 on 1 plus 0 is 1 plus c, which means c equals negative 1. So, our new expression for our terms of t, I'll just see if I can fit it in up here. H is equal to t plus 1 over 1 plus t and then minus 1. Now we have to write this as a single fraction. So, common denominator, when you're adding and subtracting fractions, remember we need a common denominator. Our common denominator is going to be 1 plus t, which means we have to multiply both of these here, well, t by 1 plus t. So I'll write it out fully like that. Our middle fraction already has a denominator of 1 plus t, so that means we don't need to change the numerator. And our last, I guess you could say, fraction term, our last term, also needs to be multiplied by 1 plus t, so that has a denominator of 1 plus t. So expanding and collecting like terms in the numerator, we've got t plus t squared plus 1 minus t, all over 1 plus t. And we have some like terms here which are going to cancel. We've got 1 minus 1, t minus t, so you can see we're just left with t squared over 1 plus t. And so there's our expression for h in terms of t as one fraction. So that's part A. Alright, part B says hence find the depth of the submarine after 1 minute. Alright, remember the depth is h, so we need to find h when t equals 1 minute. Now, what was t? What units was t in? Well, it's set up here that t was in seconds. So, how many seconds are there in 1 minute? Well, 60 seconds. So that means we want to find h. This question is saying find h when t equals 60. So, using our expression for h in terms of t, we are going to find h when t equals 60. So 60 squared over 1 plus 60. And that will give you to 1 decimal place 59.0 metres. Because, why is it metres? Let's say that somewhere. There we go, h is in metres. Okay, let's have a look at Alright, so in this question you see that it's a combination of rates of change and trig, because you can see the expression for our height of our tide at Descartes Beach is h equals 4 plus 2 cos of pi t on 6, where t is positive. That makes sense. T is got to be greater than 0. Time is always positive. H is the height in metres, and t is hours. Alright, find the height of the tide after 8 hours. So that is simply saying find h when t equals 8. So substituting in t equals 8, you get 4 plus 2 cos of 8 pi on 6. Alright, and using what you know about trig, let's see if we can work this out. 4 plus 2 cos, we can simplify that to 4 pi on 3, just dividing numerator and denominator by 2. We can also change this. 4 pi on 3 is an improper fraction. It's more than pi, and it is in fact pi plus pi on 3. So if we were to get the common denominator here of 3, you'd end up with 3 pi plus pi, which is 4 pi on 3. Alright, so which quadrant is pi plus pi on 3 in? Pi is over here, so pi on 3 is going to be down here. Well, pi plus pi on 3, that's where 4 pi on 3 is. Third quadrant, where tan is positive but cos is negative. So this is equal to 4 minus 2 cos of pi on 3. So our related angle, you can see there is the pi on 3. Alright, so let's work out what this is. Well, cos of pi on 3 is cos of 60, which is equal to sine of 30, using our complementary angles, which is half. So this is equal to 4 minus 1. 2 times half is 1. The 2's cancel. And 4 minus 1 is 3. So that means when t equals 8, the height of the tide is 3 metres. Alright, part 2 says find the rate of change of the height after 8 hours. Remember, the rate of change is the first derivative of the height. So that means we need to find dh dt. So we've got our expression for h there. Let's find dh. Alright, I might start up here so we've got a little bit more room. dh dt equals, so the derivative of 4 is 0. When you're differentiating cos, you get negative sine, and it's going to be the derivative of what's inside here, which is pi on 6. So it's going to be negative pi on 6 times 2, negative pi on 6 times 2 sine, and then we keep that bracket bit the same, which is pi t on 6. And we can fix that up because the 2 and the 6 simplify to pi on 3 like that. Negative pi on 3 sine of pi t on 6. Now this question was worth 2 marks, so you got 1 mark for differentiating. And then the next mark is found because we want to actually find the rate of change when t equals 8. So substituting in t equals 8 to find the rate of change when t equals 8. The rate of change is dh dt, so that's going to be equal negative pi on 3 sine of pi times 8 on 6. So we already know that 8 pi on 6 can be simplified to 4 pi on 3. Yeah, so because we just did that over here, 8 pi on 6 is 4 pi on 3. Okay, so let's find what that is. So just like we did before as well, we can say that 4 pi on 3 is pi plus pi on 3. It is in our third quadrant over here where tan is positive but sine is negative. So, and the related angle is pi on 3. We've got that negative there, and this part's going to be negative, so it's going to actually be positive pi on 3. And then times by sine of pi on 3. So this pi on 3 is that pi on 3. This pi on 3 is that related angle there, and the negative, well, this is is negative. The sine of pi plus pi on 3 is negative, so negative times negative is positive. Okay, now sine pi on 3 is sine of 60. Sine 60 is root 3 on 2. And you can either leave it like that or simplify it to root 3 pi on 6. And remember, our h was in metres and our t was in hours, so our rate is going to be in metres per hour. And you can leave it like that, or you can type in your calculator, go to one significant figure, and you get 0.9 metres per hour is the rate of change of the height of the tide after 8 hours. Okay, then part 3 is saying state whether the tide was rising or falling after 8 hours. Support your answer with appropriate calculations for 1 mark. So our first derivative here is positive, 0.9. So our gradient is positive, which means that the tide is rising. There's a couple of different ways to answer this question. So you could say tide is rising. Should have been a capital T, sorry. Tide is rising. Now support, our calculation is, because the first derivative, dh dt, is positive, greater than 0. Or alternatively, you could, we've already found the height when in part A, when t equals 8. The height was 3 metres. We could also find the height the next hour when t equals 9. Whoops, that's pretty big t. When t equals 9, let's find the height. And you end up with, so you get 4 plus 2 cos of 9 pi on 6. And 9 pi on 6 is going to simplify to 9 pi on 6 will simplify to 3 pi on 2. And if you put that in your calculator all in one go, you get 4 metres. So when t equals 8, height's 3 metres, and when t equals 9, an hour later, the height's 4 metres. You can see as well that the tide is rising. It's risen from 3 to 8 metres. So you need to answer the question first, state whether it's rising or falling, and then you need to also support your answer with calculations. So put in some little bit of information like that, or a little bit of information like this. Okay, for the 1 mark. Alright, question. Alright, now I've just made the question a little bit smaller to fit in some more working out on this page. Alright, now a tap releases liquid A into the rate of that, litres per minute, where T is time in minutes. A second tap releases liquid B into the same tank at this rate in litres per minute. The taps are open at the same time and releases the liquid into an empty tank. Show that the rate of flow of liquid A, so there's our rate of flow of liquid A, is greater than the rate of flow of liquid B. The rate of flow of liquid B is that one there, by T metres per minute. Okay, so we have to show that the difference in these rates is T. So we need to show that 2 plus T squared on T plus 1 minus this other rate for liquid B. We have to show that somehow this equals T. So that's just, algebra. Basic arithmetic and algebra, topic 1 from the prelim course. So common denominators, like terms, algebraic fractions, all of that. So we've got 2 plus T squared on T plus 1 minus 1 plus 1 on 1 plus T. So obviously when we expand these brackets here, this is going to become minus 1 and minus that bit. So we've got 2 minus 1, which is 1. And then we have T squared on 1 plus T, or T plus 1, minus 1 on 1 plus T. Alright, well, we've already got a common denominator there, so that makes it a lot easier. So it ends up just being T squared minus 1 on T plus 1. How convenient that our numerator is, going back to that first topic from year 11 again, difference of 2 squares. So we end up with T minus 1 and T plus 1. And our denominator there is t plus 1, and you can see that we will cancel our t plus 1s. Oops. So we end up with 1 plus t minus 1. 1 plus t minus 1 is equal to t, which is what we had to show. We had to show that the difference in the flow rates, which of liquid A and liquid B, is t, litres per minute. Okay, so then part 2. The taps are closed after 4 minutes. By how many litres is the volume of liquid A greater than the volume of liquid B in the tank when the taps are closed? Alright, so we want to try and find the volume now, given the rate. And then we also have to find the difference between liquid A and liquid B. So if we were to find an expression for the volume of liquid A, it'd be the integral of this. And if we want to find an expression for the volume of liquid B, it would be the integral of this. And then we would have to integrate both and subtract them. Now, we could really, using part 1, because we're finding the difference of both, and either you can integrate both and then subtract, or you can subtract first and then integrate. And that's going to be our easiest option here, because if you can see, our liquid A, if we will try to integrate this, it would be very difficult based on the skills that you've learned in this 2-unit course. Okay, we can't just integrate this second. It'd be easy to integrate the 2, but it'd be really hard to integrate this second term. That's more of something that you would do in extension 2. And our expression for the volume of liquid B is going to be the integral of 1 plus 1 on t plus 1 dt. So, the question is asking for, by how many millilitres is the volume of liquid A greater than the volume of liquid B? So, that's going to be our volume of liquid A, and that's going to be our volume of liquid B, and it's after 4 minutes, so really we're finding the integral between 0 and 4 for both. But we're finding by how much is liquid A greater than liquid B, so it's this first integral minus this second integral. Now, the difference in volume, you can see, is going to be the integral between 0 and 4 of this expression minus that expression, which is what we already did over here. 2 plus t squared on 1 plus t minus 1 plus 1 on 1 plus t. You can see that all equaled t. So this minus this is just equal to t. So we're really just finding the integral of t. dt. So much easier to integrate. So using part 1 to help us to work out part 2. So that integral is going to be integrating t with respect to t. It's t squared on 2. That's between 0 and 4. So 4 squared is 16 on 2 minus 0. So our difference in volume is going to be 8. And volume was in litres. So there's going to be 8 more litres of volume A, of liquid A, than liquid B in this container, in this tank.